Perfect. Thank you so much.
Okay. Can I start? Is it ready? Okay. So my project is called Pack, and I was looking at kind of a variety of different types of bags and packs that people wear. So not focusing on any specific type, but focusing more on what they have in common in terms of the types of materials and the types of assemblies that they have. So for instance, kind of in common between any of the types of bags are things like handles or straps, enclosures, compartments, different amounts of flexibility or expandability, and then sometimes kind of structure or stiffness built into the material. And then normally these things are focused on assemblies of multiple materials, often through seams or through sheet material. And in my project, I wanted to try something different. So my objective was to generate a range of contrasting material properties using a single aggregated, what I'm calling a unit part. So rather than having this kind of assembly focused way of achieving different material properties, I wanted to do all of that through the parameters of my system. And so how this works is I have kind of a single part that can change shape and change some other parameters, and it's developed into a kind of network of parts through a simple translation. So two-dimensionally, the part is just rotated with itself and then copied into an array. And three-dimensionally, a similar operation to turn it into kind of a gridded array of parts. So whatever geometry the single unit starts out as, it can be used to form a kind of whole grid of that part. So using this premise and developing a design space around this, I wanted to use this to generate a lot of different material properties. So in my design space, there's kind of three main categories that I was working with. So first, expandability, then grid density, and stiffness. So these were the three ways that I was trying to manipulate the unit to make material properties. So first, with expandability, I was kind of referencing this idea of a simple plastic bag that can kind of expand to many times its crumpled size to store objects. And so the idea is that the unit, depending on how it's manipulated geometrically, it can either expand almost none, or it can expand really significantly its original size. And this is achieved with a few parameters in the formation of the curve geometry of the unit. And so in some of the labels, you'll see the U-loop or the handle that refers to kind of the base of the unit, or the radius, which is kind of an input parameter that controls the shape of the top of the unit. And as you see, with those parameters manipulated and the unit copied, they can form kind of a whole range of different curve shapes when the unit is aggregated. And then turning this into 3D, imagining that those units are kind of 3D printed as one contiguous surface made of flexible material, and you can get something that expands multiple times its length. And so you can see there's a whole variety. So with all the other parameters the same, if just the shape of the unit is manipulated, it's possible to make a pretty wide variety of different expandable shapes. Next, a little bit more simple, but another area of the design space is the grid density. So the ability to change how densely the units are packed with one another. And then finally, the stiffness of the material, which is manipulated just through the material diameter around the curve. So depending on whether it's a really expandable shape or a non-expandable shape, the material thickness can either join everything together to make it kind of very thick, or it can be left very thin, and through that manipulate the behavior of the overall kind of block of units. And so here's an example of the same geometries, but with very different behaviors through the material thickness. And then these parameters, so the 3 parameters can also be used in kind of ranges. So for instance, you could have different expandable properties kind of within the same surface all at the same time by applying the parameters differently across all of the units. Similarly, you could have a range of material thicknesses in the same block of units. And then likewise, you could also have different discrete properties, in particular applied to material stiffness. So separating the directions of the units and being able to apply different properties to each of them. So with that in mind, the idea of those 3 kind of major areas of manipulating the design space, thinking of a pretty conventional backpack and how that might apply, I was thinking of the different kind of types of materials that composes a backpack. So each one of these kind of categories I developed into a material using my unit. And then kind of imagining that because the unit and the design space kind of is pretty flexible, imagining that it could take on the characteristics of not just conventionally what's inside the backpack or whatever kind of bag, but it could take on kind of textile-like qualities, or it could exhibit patterning or other things that would kind of normally be associated with garments. So for each one of these materials, I kind of mapped out with those 3 categories what I thought the ideal characteristics within the design space. So I was kind of thinking through this for each one, and I'll kind of go through each of them to kind of demonstrate the ability of the unit to shift between them. So here with the expandable membrane, so imagining that this is part of a bag that can expand and contract. So it has really high expandability, kind of medium density, and then kind of low stiffness, so it stays flexible enough to expand and contract. And so this would be kind of areas that kind of need a lot of change or expansion. Then kind of opposite of that, just having the unit become a surface. So here it's really thin and it's not expandable at all, but it has a really high density in order to achieve that. And the result is more kind of surface or texture oriented. Next, being able to make some sort of mesh that's kind of thin and fine and flexible, but not too expandable. Kind of a little bit more simple. Something that is kind of stiff and sturdy, like a handle or a strap, but also has some kind of directional quality to the way that it behaves. So not expandable, but kind of dense and stiff. Next, imagining that kind of sometimes you'd want a material that expands really significantly in one direction, but not in the other, kind of like a duffel bag. If you want to pack it down, it has kind of behavior in one direction a lot more than the other. So here, using kind of 2 different material properties assigned to each direction of the grid. A structured cushion, so being able to fuse material in some areas and leaving it kind of thin in others, so that it's both kind of thick but also has flexibility because the kind of thickness of the material is applied to kind of one face of the grid or the other. a structured base. So this is kind of the sturdiest or thickest, like really structured way of using the unit. So giving it a really kind of lower density and thick material to make something kind of completely different from the more flexible pieces. And then finally, kind of the two areas that are more like a textile. So here I'm manipulating the parameters so that the grid directions don't touch each other, which makes them interwoven. Yeah. And then finally, okay, I'm very close. And then just being able to apply patterning. So with the design evaluation, some of the parameters are much better lended to some methods of evaluating than others. And so I used both optimization and simulation and some subjective evaluation. So with the optimization, it was possible to work with the unit parameters in order to achieve some kind of metrics or numerical goals, like the amount of expansion or the difference in expansion between one area of the kind of block and the rest. And so this is an example of one of those explorations that I did. And I was able to use optimization to get a range of different characteristics. And then with simulation, that's kind of that's better lended to understanding the material stiffness. And so earlier on, I explored that as a method of evaluation with the behavior of the different expansions. And then finally, the subjective evaluation. So I was trying the whole time to avoid things like this, where there's kind of a chunk of one property embedded in a chunk of another property. And to avoid that, that's where I use manual adjustments and just kind of visual evaluation. So through just simple attractor points or using the graph mapper, those were my two kind of manual design manipulations that I was kind of always performing. And then there's kind of evidence of that in the kind of final set of kind of material swatches that I've made. And then in kind of the next steps, if I kept working on this project, I would obviously want to do physical iteration that I wasn't able to do because of this semester. I would want to kind of work on the workflow of integrating all of these properties and the unit parameters into the whole object and kind of the modeling workflow that would go along with it. Great, thank you.
Thanks, Lavender. I'll just open it for the reviewers because we kept talking about these all through the semester. So.
Hi, Lavender. Thank you for the presentation. I have a question. Did you consider, because we saw all your experimentation happening on this flat plane, and I understand that this was a choice of, associated with the parameters you chose to develop. But did you think of the ability of these units to make a curved surface or to explore the limits of the curvature that this surface can take?
Yeah, so I definitely wanted to do that. And I think now that I have the parameters and kind of how they're deployed with each other, I would see that as being kind of the immediate next step, because I think there would be a lot of exploration to do with how all of these then relate to some other form or being applied to forms. And so if I kept working on this, I would definitely look forward to doing that. Yeah, definitely.
Yeah, because this already created a very broad and super interesting design space. But I imagine that depending on what materials you choose to test it in real life, it will generate many, many more. For example, if there are stiff components that could create friction between them, or if they're solid components, or if it's fabric. And I know that you're working with textiles, this could be something totally different. So what materials would you think of developing it?
So I guess I imagine this being made of kind of one homogeneous material. I wouldn't know which one without trying it physically, and then completely using the unit parameters to kind of change its behavior. So it would be kind of one solid piece of material, but just using these manipulations to kind of tease out the right behaviors in different areas.
Yeah, I think that many of the properties you explored would be super helpful in actual user evaluation or computer simulation if the physical option is not possible. For example, in the bag example, you have the edges that wear out very easily, or the handles. So I think that this would be a great system for tackling problems like that we see.
I have a question for Lavender. Thank you for your presentation. It's really great. I like it a lot. Have you, because most of the things that you presented right now, you can say, for example, that are like 2.5D because you're exploring like surface type of pattern. Have you considered the idea of, for example, like adding layers? Because you have like now these different patterns with different properties. For example, a layer that is more stiff versus one that is more like, let's say, like expandable. So in that, let's say, like very like self-assembly or 4D way, basically create, for example, like pockets or generate like another type of geometry, basically explore like the height, not only like depth and width, but also height of the possibilities with this pattern.
Yeah, yes, I totally agree. If I were to add a fourth category to my design space, it would be about forming layers between sets of units. And I think that would develop into, like if this did become an object, and that how the layers kind of join and separate in relation to the geometry would become kind of another part of kind of what's being controlled with the units. But then I kind of stopped. I stopped before getting there. Yes.
Yeah, no, because it looks super great. And one might think that, I don't know, maybe like right now, the way you have it, like a kangaroo simulation, for example, of just like the way you have it right now, it's just like seeing what happens when you apply actually like digital physical properties to your simulation, and then to start thinking about how can you basically start in a very similar way how, for example, like clothes work, right? You have like insulation or like a outer like fabric or whatever, and they behave in a different way, and that also has like an inherent complexity, you know, to come up with the final product. But I think it's super great. I like it a lot, and congratulations.
Hi, Lavender. Thanks for your presentation. And kind of continuing what Diego was mentioning with the garment idea, I think your sketch with the human figure and where you grayed out the front and the back areas is really intriguing, because that suggests a departure from like the original backpack images that you showed. And I think you are exploring this design space that's very continuous. And so it could start to become more like a garment, like you were describing. And I think if you can break away from that like traditional backpack idea, maybe these swatches and things would start to come together, and you can start to layer them and like assign functional areas to that shaded sketch. So I think this was like really great exploration. And definitely, like you mentioned, the next steps actually printing the physical material, thinking about the material properties and how all of these could come together in a continuous way. Be a great next step.
We are, in the meantime, we are joined by Chris. Chris, I introduced you before you joined, so pretty much everybody has an idea who you are. If you guys have any more feedback, we can use a couple of more minutes before we switch to the next presentation. Okay, thank you, Lavender. I think you came a long way. What I appreciate about your designs is that you constantly kept adding value and complexity by doing more inquiry during the semester. So thank you very much for that. And I think the latest map, the parameter space that you're bringing back in is something, again, I didn't see. Even last week you didn't have some of these. So definitely thank you very much for that. I think and there's more to this. I'm aware that it's impossible to, present everything that you have been working on in 10 minutes. It's very hard. And I know there's a lot of background, and for everyone, including the simulations and optimizations that you have been doing. One setback I just need to tell is this class was about digital manufacturing, right? So we were able to print things only for the first 4 weeks or 3 weeks. So after that point, we had to kind of immediately change the syllabus in a tremendous way, right? So something that started targeting for something very tangible immediately kind of disappeared. So thank you for the extra effort for that too.